This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's episode, we're going to talk about a crazy video of a bunch of skydivers jumping out of a plane, and which sent this King Air aircraft into a spin. We'll talk a little bit about the aerodynamics involved there and how this pilot just easily and pretty nonchalantly recovered from this. Pretty crazy video. We'll talk about the Rolls-Royce has successfully demonstrated a 100% SAF powered flight. So talk about some of the implications there, as well as just the overall fuel consumption relative to SAF globally. A little bit of Boeing news. They've had some pretty high losses in the third quarter because of the 787. And we'll talk about Wright Electric with a big press release about their plans for an all-electric 100-seater by 2027, making a lot of headlines. And then in the EVTOL segment, we'll talk about a unique Boxwing design coming out of Australia and some of Volocopter's plans for testing over in Rome. Okay, so Alan, this crazy video of a King Air dumping out a bunch of skydivers, I guess they really overloaded the side. Why would that cause a plane to go into a stall?
Well, I think two things were happening simultaneously. One is that they had reduced the power on the left side engine, on the pilot side engine. And so they're using the right engine to provide the thrust. That's so they're not putting the skydivers in the prop wash. And then they had a bunch of skydivers hanging off the side of the airplane, which was blocking the horizontal stabilizer, the left side of it. And so you really mess with the aerodynamics enough that it kind of stalled the airplane is what it did. And because you just get this dynamic of uneven tail force. And so the airplane kind of rolled over on everybody, and all the skydivers let loose because you really had no choice at that point. They were getting dumped out of the airplane, whether they liked it or not. And then the really fascinating piece of this video is you can see the airplane, try to avoid skydivers as it's descending and into this spin stall situation. and you can kind of get an outsider's perspective of what that looks like. And the thing to do, and what I think they did also, is you want to reduce the thrust on both engines, put the nose down, recover, then apply power. Again, that's the typical stall scenario. So I haven't seen that before, and I'm not even sure that the King Air is rated to do that kind of maneuver. I know the King Air is just a really tough airplane. I'm sure it's been through all kinds of flight testing for as old as it is. But I wouldn't want to make a habit of doing that in a King Air. Getting in odd spins and changing the aerodynamic performance of the aircraft is not something to play around with. And that's why they pay flight test pilots a lot of money to go do that.
Yeah, well, the pilot sounded really savvy, just his quotes in this article from AVWeb. But he mentions that he, just tried to sort of smoothly ease out of it once he started his recovery maneuvers to avoid stress on the airframe. So what does he mean by that? What does that mean to avoid stress on the airframe? Like if he didn't do, what is he worried of doing to the aircraft?
Applying too many G's to the airplane, which is only rated for a certain amount of positive and negative G's through the flight testing that they did when they certified the airplane back in the 50s. But there's certain limitations, and what you're afraid of is you're going to start bending the tail or start bending the wing spars and deforming it. And once you do that, you kind of make the airplane almost trash when that happens, because it takes a lot of inspection to go. If you over G it, if you apply too many G's, you got to do a structural inspection on it, because you may have cracked, warped, bent something really important, and you don't want to fly it that way. And that's what they're talking about. So that's why in a lot of cases, like in this particular case, so you want to kind of throttle down and not overload the airplane. But the wild card here is you got there's like 6, 7, 8 guys jumping out the back of this airplane. Like they're floating around with you in your immediate vicinity. The chances of you bumping into one of them is not zero. It's actually probably pretty high, right?
Yeah, you see that in movies where, like, for example, James Bond will catch up to a falling airplane. I guess that is somewhat possible. Obviously, it's very, movie-esque, not real life. But at the same time, you could fall faster as a human in a tuck, kind of falling like a teardrop, than a plane with its big wings kind of falling more slowly. So I guess you're right that there is a non-zero chance that this plane could be kind of tumbling and hit one of these skydivers who's trying to, catch air and float a little more than they are trying to go down like a bullet. So yeah, that's a really scary scenario to think about that. Oh, here comes the plane after me. Good grief.
Well, that's happened in military. I believe, and it's been a long time since I've read these things, and when you've actually had something about military aviation, but I thought there was a case or two in which people have ejected out of airplanes and the airplane has come back at them and either nipped them or gotten really close to them as the airplane crashes, right? And I thought, for some reason, in the back of my head, it thinks like that happened to Chuck Yeager at some point. Like Chuck bailed out and the airplane was in his general vicinity as he's descending. Yeah, so airplanes running into people is a thing that in theory can happen, and I do believe it has happened on the military side, and hopefully it's never happened to the skydivers. I'm sure if we go back through the records of all the skydiving accidents, there's got to be one where a skydiver's been hit by the airplane somehow. And this is a really dangerous situation. Obviously, you just never want to stall an airplane as people are jumping out of it. That's just really, really risky. Yeah. Crazy.
Well, moving on, Rolls-Royce has tested with a 747 a 100% sustainable airline fuel test. Obviously, this is a really hotbed issue right now. Alan, I don't know if you noticed, but did you hear about that world was like a renewable energy conference that Jeff Bezos and many other world leaders, if you call Jeff Bezos a world leader, I mean, he's a leader in business for sure. I mean, he's one of the best businessmen of our generation, like him or hate him. But people gave all these leaders a lot of flack for taking private jets to this meeting. And, it's like you're not allowed to travel any way, sort of way, except by like oxen in today's society. But I digress. But, people are talking about SAF a lot more. And I know Jeff Bezos, for one, he said that I used only SAF in my private jet, which he's got the money to do that, clearly. But this is not typical. Yeah, I saw him say that. There was an announcement that like his private jets were like a neutral carbon footprint. So at least from that standpoint. Anyway, so yeah, again, I mean, take it with a grain of salt, but I was reading some of these articles about just the rage about the carbon. It's like, these private jet flights sure are more than if they all took commercial flights, but they're also about to donate lots and lots of money to environmental causes. And, it's just unrealistic to ask. I mean, I guess here's a question for you that off a little bit off topic is, should private jets be outlawed because of carbon? I mean, there's just a lot of hatred between the super greenies and I think just a realistic view of the world right now and how people travel.
Yeah, I understand. I understand the concern, and on some level, I agree that we should, try to reduce the fuel burn and the carbon emissions that come from aviation. And aviation in general has done a really good job at that. I think that when it starts to feel uneasy is when you have two people flying on a large business jet that doesn't feel right to people. And okay, I kind of get that. But there are a lot of and there's a lot of business scenarios, or even in insurance scenarios, where like if the heads of like Amazon, you don't want to put all the heads of Amazon on a single airplane, because if it crashes, the whole top level of Amazon is gone. So insurance wise, they're not allowed to do it. But there are a lot of places where you have to get, particularly in the United States, that are not easy to get to. And it takes forever to get to, and time is money. And if you're trying to conduct business, having a business aircraft is the right way to do it, because it's easier to get in out of, if you're not going to Dallas or Atlanta or Chicago or one of the major hubs, getting in and out of an airport can be a really hard time. If you're like going to Bismarck, North Dakota, if you had a business up there, what are you going to do? You're probably going to fly something that's smaller and faster to get in and out, just to save time. So there's a rationale for it. The conference over in Ireland is a little bit of a different scenario because they're trying to do some political action. But, there's just no way you're going to remove a form of travel that is so ingrained into not only United States activities, business activities, it's ingrained in world activities. Be impossible to back away from it now. Yeah.
Yeah. So back to Rolls-Royce, the usage of SAF is still very, very small. Pre-COVID, we were consuming as a planet 98 billion gallons of fuel in the aviation industry, and that plummeted to 52 billion, so almost cut in half after COVID, and now it's recovering to projection of about 60 billion gallons in 2022. I mean, what percentage of that do you see being SAF in the commercial sector, Alan?
Well, I thought they were only allowed to use certain blends on older motors, right? And so if you have a particular jet engine, you're only allowed to mix a certain percentage.
Only 50% right now.
Up to 50%? Okay, that's a lot. All right. Yeah, but even then, the production capabilities of SAF are really limited at the moment. So even if you wanted to make SAF universal tomorrow, you couldn't do it because you don't have the infrastructure to make it. And I think that's going to be the limiting factor. It's not so much that aviation won't use it, and I think there's some drawbacks to it, but you just don't have the production facilities to make it. So you can't use it. So what are you going to do, right? If you create such a huge demand for it, and you're only making 10 billion gallons, that's like roughly 1/10 of the world's needs for it. So it takes time, and I've just seeing some articles about the push to get the U.S. to 100% SAF by 2030. Well, yeah, okay, if the airplanes will tolerate it, one, and two, if you have the production capability to do it. You're 9 years away from that, or 8 years away from that, roughly. It's going to be really hard to do that. Really hard to do that. Yeah.
And then other concerns here, moving away from renewable energy and carbon emissions, is 5G, which seems like it would have, I don't think any of us really think too much about what's flying through the airways, but the FAA has some concern about the new 5G network that AT&T or Verizon are planning to roll out here in the U.S. And of course, 5G networks are already in operation in some other countries. But Alan, why does the FAA have such pause right now and concern about this 5G network?
Well, anytime there's a spectrum usage or a shift in who's using what spectrum, it can affect the FAA because the airplanes operate on all kinds of frequencies around the spectrum. And particularly if you have older equipment, in this particular case, radio altimeters, which are telling you how high the aircraft is above the runway, some of that older radio altimeters can be susceptible to 5G signals. So your radio altimeter is not working correctly. And it's not like the radio altimeter is using those frequencies. It's not. But the receiver reacts to those frequencies. So you'd have to, and what the FAA is saying is the 5G spectrum and how it's going to be used could affect airplanes, and in particular in a critical phase of flight, landing. And if the radio altimeter is not working, then that's a decrease in safety. That's not good. And to retrofit all these airplanes with some sort of filter so that it would block the 5G signals, well, one, you got to certify it. Two, you got to install it. Three, the complexities of that are massive on a short time frame. So what the FAA is saying, like okay, everybody slow down a minute, because we don't want to put airplanes at risk. We could work on a solution. Wouldn't be all that expensive, but we have to mod a bunch of aircraft and make sure that we don't degrade the performance of the radio altimeters when we mod it. So there's just a lot of gyrations here. And we had a similar situation, Dan, several years ago, with GPS antennas and VHF radios, and there were some spurious emissions from the antennas, from the GPS antennas and systems, that would cause noise in the VHF communication radios. That was a big deal, and so they would. When everybody figured it out, what they did was they separated the antennas. They actually physically moved the GPS antenna away from the VHF and put some rejection circuitry in there too to help get rid of it. So we're constantly monitoring for RF emissions and noise and system performance based on what's going on with the spectrum. I'm just shocked, and maybe, Dan, I'm wrong, that they're not slowing down. Like the FAA is getting really concerned about this, and we're starting to see articles about it, because maybe there's a lot of consumer interest in having 5G, which I'm sure there is. But how are we going to mitigate the FAA's true problem? I'm not sure there's a balance that has been made yet. Have you seen anything that says we're going to resolve this?
No, and it said that the FAA doesn't have any real evidence that it is interfering or it will interfere. But yeah, I don't know how you test that either. I mean, how do you figure that out? You just get a bunch of planes with people on it and see if they. I mean, yeah, test pilots, or what are you doing?
Yeah. So in a case like Hector and I've done on airplanes, you actually can simulate those environments in a hangar somewhere or outdoors somewhere, where you can simulate that effect to see if the aircraft reacts to that. Because my guess is, if you think about airplanes and how old some of the electronics are in airplanes, there are airplanes that are flying around with electronics that was designed and manufactured probably in the 1970s. So you have 50-year-old stuff out there. Now, radio altimeter may be a different beast there, but it's going to be several decades old. It was never envisioned that 5G was going to be a thing. So it's almost inevitable. There's going to be some systems that react to this 5G spectrum. That's why everybody needs to be checking it, and that's why the FAA is so uptight about managing that spectrum.
Moving on, we're going to jump to Boeing here. So they posted a higher than expected third quarter loss. Their 787 Dreamliner, which has been quite the embattled plane, has sent them into a tumble. Alan, is this going to just continue to be a trend and a drag on their bottom line?
It will be until they can get all the engineering and manufacturing issues resolved. I'm not even sure if the issues are sort of core to the design, or is it just a manufacturing issue on a training side that there seems to be a disconnect?
Mm-hmm. They've had just problems with parts fitting together and the way they've been manufactured. Yeah, it seems like tolerances have been poor.
Yeah, the tolerances are not quite there in the way they have to shim things together, which is an allowable process, and it works really well. But it is a technique, and it's something that needs to be refined, and it takes training to do. But if there's been an escape in the way that the structures are put together, or the way things are aligning, or there is some sort of weird tooling issue, or parts becoming oblong from sitting out in a parking lot, you're just going to have to fix that. And it's going to take engineers time. And that's what everybody hates, is having engineers run around spending a bunch of time trying to solve it, and then secondarily try to put in processes and planning and manufacturing oversight quality systems that stop it from happening. That just takes so much time, way more than you would think, honestly. And that's what Boeing's paying the price is. I think they know. Management, I'm sure, is not happy about this. I'm sure shareholders not happy. But Dan, I think it's going to take, from first notice of this, something significant, major happening like this, 6 months to a year of just constantly working to figure out what the problem is and to resolve it. And in the meantime, it just hurts. Yeah, it just hurts. It's like fixing a building. Airplanes are so massive. If you built a house, and say you're building a tract of houses somewhere, and you had a roof joist that wasn't lining up right and causing you problems, well, you have to go back and fix all that. That's going to take a while. It's going to take a while to design it and engineer it right. Boeing's in the same situation.
Funny you use buildings as an example. We've talked, I think, on our other podcast about the Millennium Tower, and that's in San Francisco, which is a luxury high-rise, with $10 million condos in it. And it's been sinking. It wasn't, pile-driven deep enough, the foundation, into the where it got to the bedrock. And so anyway, it's sunk and it's leaning slightly. And so they've been trying to fix it. And like you said, their initial fixes that they're doing right now, which is driving deeper piles into the ground, has actually caused the sinking to go faster. So it's sinking even more. Now they're fixing it. And so they're like, wait, what are we doing? We need to stop. And so it just, yeah, it seems like a similar kind of parallel where things just weren't right, and now they're tinkering and doing things they think are going to fix it, but they're not fixing it, and it's getting really even more complicated. So sorry if you own a $9 million condo in that building. Life's really hard for you right now. And speaking of which, Wright Electric has announced their 100-seat electric plane, and they, in the press, believe will be ready by 2027. And of course, the Boeing thing just sort of highlights just how difficult it is to bring a new technology to market. The 787 is not even new; it's just high tech. But I mean, Alan, is this 2027 is really far away? Why is this in the news cycle now? Just, I assume, to help this startup get cash and sort of get some momentum.
Yeah, absolutely. I think you nailed it right on the head. It's all about cash, momentum, and people, and enthusiasm, and getting the project off the ground. If you look at their website, which is really fascinating, by the way, they're talking about making 2-megawatt motors. And a 2-megawatt motor, you think to yourself, 2 megawatts. Like when we do a wind turbine podcast, and a 2-megawatt generator, yeah, a 2-megawatt generator is like the size of a car, all right? It's a big thing. But this 2-megawatt motor is about the diameter, I don't know, about 2.5 feet diameter, maybe, if that, maybe a little tighter, maybe 2-foot diameter, like a trash can size diameter for a motor. And you're like, man, there's a lot of energy going through that component. 2 megawatts, and what are you doing with all the heat, right? So the technology to power that is incredibly complicated. So it's going to take a couple years, I think, to really flesh out the reliability of such a system, and also to design it such they can withstand the rigors of all the different flight profiles it's going to be. But the other thing about this Wright motor was it's not a propeller-driven thing. It's like they're going to stick it in where like a jet engine would go. So it's like a ducted fan is what the concept is. Like, wow. We haven't really seen a lot of that lately. And because there's just some flight things, profiles with that on the aerodynamics, just doesn't really play out very well. So it's interesting. I think the concept is really interesting. They're going to use a BAE 146, right? Which is the British Aerospace 4-engine high-wing jet aircraft, which at one point was the Queen's airplane. Like the Queen of England had one of those when she flew around. That's what she flew around in, her own sort of private jet. So it's been around a long time. The airplane's very well proven. I've flown in that aircraft a couple of times. A nice airplane. So on the development side, I think they're making the right choice on picking an older airframe that they can modify to put the motors in. But Dan, don't you see this is going to take? If they have it done by 2030, I think they're doing really, really well. Don't you?
Yeah, it seems like a really hard problem to solve. I mean, they like you said, they break it down really well on their website, weflyright.com. It's obviously with a W. But yeah, they're talking about breakthroughs in their propulsion system, their inverters, motor size. And I mean, it seems like there's a lot of things that have to go really right for it to work the way they hope it does. And again, when you start to look at some of these, how long has Boeing been around, and they can't get a traditional aircraft right. And again, not that bodes poorly for any other company, because they have their own issues, but yeah, it just seems like it'll be a really difficult problem to solve. But everyone does want electric planes. So, and like you've said a number of times, it's not a short time scale; it's a long timeline. So I guess the timeline makes sense. It's just like you said, it's a long way away, and they're gonna have a lot of funding to stay on track. So moving on to our EVTOL segment today, we're going to talk about just two quick designs. So number one, there's a Boxwing EVTOL from AMSL Aero out of Australia. Alan, Boxwings, why don't we see these that much? I mean, they're out there, but what strikes you as unique about this design, and do you think it's going to work?
Well, a Boxwing's a kind of a unique wing, and you don't see it in any sort of production aircraft. I've only seen it sort of on radio control models, but I think the issue with it tends to be flutter, that without the right stiffness and dampening coefficients, that the thing can kind of start to flop around and come apart, which is why you don't do it. But in this particular case, I think these guys have got it figured out, and they actually have a prototype, which was I was shocked how far along this aircraft is, because it seems like it takes a good bit of time on a unique aircraft configuration to put it together and to like do some validations on it aerodynamically to make sure the thing will fly. But they have almost a flying prototype. It's close. I don't know when they're going to first flight this thing, but it's not that far off. And the unique feature of it is the engines, their electric motors and propellers, they pivot, and basically the back half of the wing moves with the motors. So you're kind of getting a quasi change in airfoil shape while you do this thing. So it's an interesting concept, and what they're saying is its lift to drag ratio is really high, which I think that's right. And the question is, can you keep it stable enough and strong enough that it doesn't want to come apart, which is what they're going to go flight test for sure. But I also think the interesting piece of this is the Australia aspect of it, because you don't see a lot of aerospace technology coming out of Australia. So it's really good to see. You know, Wisk was part Australian, or is Australian now, and now we have this kind of a spin-off company, what it looks like. That's good. That's good. You know, getting Australia back in the airplane space is good for Australia. It's good for everybody. It's cool.
Yeah, well, and the EVTOL model works there because you want to get to altitude quickly to prevent kangaroos from just jumping into the cockpit willy-nilly, you know, or if a herd of, you know, gigantic spiders is chasing you, you want to be able to, you know, take off, just like in a movie where the world's collapsing behind your hero as he's trying to get away. I digress, but yeah, it is a really unique design, and like you said, they do seem really far along. You know, I don't know, you've talked about these open propellers being close to the cockpit, and they're surrounding this cockpit. I mean, is that really a big concern? I mean, obviously they're not going to fire it up till everyone's, I'm sure, safely inside, but there's a lot of exposed propellers for sure. And like you said, if one breaks off, they all seem to be aimed kind of at this at the cockpit. Yeah,
and that's the concern, right? I think we've seen some other sort of single occupant, single pilot eVTOLs that don't look mechanically stable, and which also put the propellers close to the ground in certain flight regimes. Yeah, that's why I think that's why I think you see the Betas and the Jobies and the Kitty Hawks and the Whisks all kind of keep the propellers up above the passengers. And that makes a lot of sense to me. Yeah, getting too close to the ground is a problem, I think.
Yeah. Well, last question is, I mean, obviously everyone wants to throw their hat into the ring, and you know they believe they have some unique flight characteristics, and like you said, the power to weight ratio and lift to drag ratio, stuff like that. Everyone thinks their design is really unique, but when you start to see designs that are pretty far off the beaten path, what are the advantages of doing it that way? Like, why not just sort of stick to the more conventional, like the Volocopters and the Jobies, like you've kind of discussed?
Yeah, I think it's a combination of, are you using the materials wisely, the cost to manufacture it, how big the aircraft is, can you store it in a hangar or in a garage? If you're talking about single pilot operation here, those are things that matter, right? If you have to store your aircraft at an airport and you got to pay for the hangar, that all adds up. Versus if I can put it in my garage or just leave it out in the back of the house, that's a different thing, right? So in terms of sort of manufacturing costs technology, operational costs, all those come into the aircraft design, and it's not just one of them. I think that's why, if you look at the Joby design, it seems to be headed towards an Uber environment. Like, that's not going to be piloted by the general public at all, or regular pilots. It's going to have very trained pilots. That's a specific marketplace they're going after. Everybody else is going after a specific marketplace. They're not all going after the same set of people. And that's why you see the variation in designs, because they're designing for a very specific set of pilots and a very specific income level, I think, that can afford these things. So you're going to see a lot more of these unique designs that have what we consider odd constraints when we look at a 737 versus these eVTOLs. They're just going to be totally different animals.
Well, speaking of Volocopter, they are in a partnership with the city of Rome to try to bring their Volo City EVTOL to life there. And that, of course, that's a relatively smaller one. It's got a top speed of 68 miles per hour. It's got the 18 rotors on top, kind of like that antlers kind of configuration, which again, like, seems like pretty safe, out of the way, kind of like a helicopter. But Volocopter seems to be moving pretty fast, trying to get the helipad, or just the little airport heliport, whatever you want to call it, get that going. So, I mean, Alan, why do you feel like Rome is a good candidate for this?
I think visibility. I also think traveling around. I have never been to Rome, but my understanding is traveling around Rome, because of all the tourists, can be very difficult to do. And so there's a certain income segment that can afford to fly across Rome to get from place to place. And Volocopter those guys on the marketing side seem to have their heads screwed on pretty straight. They're going where the marketplace is, and they're demonstrating it where the marketplace would be, and they're trying to introduce it to the marketplace now, basically to capture a percentage of the marketplace as much as they can before everybody else catches up. Because Volocopter is 2, 3, maybe 4 years ahead of everybody else, so to speak, in terms of having a commercial operation. Maybe EHang is the only one would be their competitors on but a different part of the planet, but they would be their real competitors today. So Volocopter is moving very quickly, and I think they make some really nice connections in Formula One in terms of being in that sort of higher end marketplace, which is where Formula One likes to advertise in. I think it's just grabbing market share, and the success of any business, regardless of what it is, aircraft business, car business, building buildings, it's all about revenue and keeping the thing sustainable. So you got to start making cash, right? You got to start paying these things off, and Volocopter is trying to start paying the bills. That's a smart move, very smart move. Don't you think so, Dan?
Yeah, and of course, right now the Volo City EVTOL it's on display in Piazza San Silvestro, right in the middle of the city of Rome. But of course, there's a caveat here, which is that it will be a 2-person capacity aircraft, one of whom is the pilot. So this is one passenger. So the idea that people are, if you're traveling, you want to see Rome, I mean, it's got to be a solo person, right? So this is, if you're a couple seeing Rome, this isn't going to work for you. It's got to be one human going to and back from the airport. But you got to start somewhere, right?
Well, isn't Volocopter working on a larger passenger? Like, it's basically a 4-passenger, 3+1. Yeah, and so, but again, it's a smart move. Start getting it out there, and I think what they'll do is just start flying Formula One race car drivers from their hotel to the racetrack in this thing, which is going to be a massive publicity capturing event. It just brings up the name Volocopter, right? It gets name recognition. It's part of that sale, right? And I think they're going after it. And when they get the larger version of it, then you can take your spouse or whoever else out to dinner somewhere. That's where they're going, and that's cool. And now let's see how it works, right? I think there's a lot of mileage to go yet, but in terms of being a leader, Volocopter is definitely out there.
Yeah, for sure. Well, that's going to do it for today's episode of the Struck Aerospace Engineering Podcast. Thanks so much for listening. Be sure to subscribe wherever you are on iTunes, Spotify, Stitcher, YouTube, and leave us a review. We'd greatly appreciate it. We'll see you here next week on Struck. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.